When we speak of the input and output mechanisms of a programming language, we often mean how it deals with local files on your hard drive, how to read, write, and generally manipulate files. As we know, in Java, input and output are mostly based on streams, and that's why we have specialized stream types to read and write files. In Java, the way you address files is by means of so-called file handles. A file handle is an object that represents a file on disk, or rather a path in your file system. It provides several methods to interact with the file, such as to delete it, to rename it, to check if it exists in the first place, whether or not it points to a file or a directory, and many other things. Let me give you a brief demonstration of how to rename a file. First, we need to import the corresponding class, import Java IO file. And then somewhere deeper in your code, you would create an instance of a file object, let's say one that points to output.txt in the current directory, and another one that say points to stuff.out in the current directory as well. In order to rename output.txt to stuff.out, you can take the file handle pointing to output.txt, F1, and call its rename to method, which takes another file handle, F2, and it returns a boolean that just says whether or not the renaming was successful. Surprisingly, this is not handled using exceptions here. Now, it is important to be aware that not every platform behaves the same when it comes to its file system. And this is because the strings representing paths to individual files in a Windows file system look different from those on macOS or generally Unix systems. In Windows, you have a preceding character that identifies the drive on which the file sits, and then you have backward slashes to separate individual directories. Whereas on Unix, you don't have these drive letters and you have forward slashes to separate individual subdirectories. At least the issue with forward or backward slashes can be dealt with by relying on a constant defined in the file class called separator, which is either backslash or forward slash depending on what operating system you're running this code on. For example, in line 3 we just introduce sep as a shorthand for file.separator. Now in line 4 we create a new file handle that uses path data plus a separator plus output.txt. And this will point to data / output.txt on a Unix operating system and to data / output.txt on Windows. Okay, let's read the content of a text file. It's reasonable to use character-based streams for that. So we're looking at the class FileReader, which is also defined in java.io. And you may remember the convention in the standard library. The suffix reader indicates that we're looking at a stream class that is character-based. So the basic unit of information that we can read of it is a 16-bit Unicode encoded character. Of course, there's a FileWriter class that allows you to write to a file on disk, character by character. Right, so what we do in line 2 here is we create a new FileReader object. And what it gets as a parameter to its constructor is the file handler object that we have created for the this-file.txt file. And now we can iteratively call the read method to get the content one character at a time. And this will return -1 if there's nothing left, if we have read the whole content of the file. So consequently, in the while loop here, we read one character at a time, and then we print out the character using the print method on system.out. I should say that this code as it is here doesn't really compile, and that is for two reasons. First of all, the code in lines 4 to 8 is not really in any method, so that is simply not valid syntax in Java. But more importantly, line 2 may throw an IO exception in case the file that you try to open doesn't exist. So in order to fix this, you can put all of this in a try block and catch IO exception.